and I'm going to put it into theater mode. And here we go. All right, here's my 3D printer. This thing, that's my furnace. That's not a 3D printer. Uh, this is an Ender 3 Pro, and I bought it in July of 2020, and it cost me about $200 at Micro Center. Typically, these things are a little bit more expensive than that, but they were having a closeout, and so I got this thing for $200. It's got some filament here on this reel, a kilogram of filament, and you probably can't buy any of this model anymore because it's been replaced by an Ender 3 V2, which has got a lot of upgrades and now costs about $260. I ended up upgrading this machine myself, and I spent more than $60 difference to upgrade it. But it's a nice little machine, and it hasn't let me down yet. There are other kinds of 3D printers called resin printers. They're a tad more expensive, but I went with the filament because it's really environmentally friendly. I teach a clinic which is Introduction to 3D Printing, and I say it's like falling in love. My wife and I will complete 50 years in October. And falling in love is complex, it's expensive, it's frustrating, but can be very rewarding. 3D printing's like that. It's as complex as DCC. This printer came with some assembly required. It took me less than an hour. It's kind of like IKEA, just pictures, no text. There are 4 stepper motors, the way these things work. This motor right here controls a belt on this shaft, which moves the carriage back and forth. This little thing right here is an extruder. It heats up to 200 degrees C, and filament comes through this blue tube here, goes down into the extruder. Right here is another motor which drives the filament through this tube. There's another motor down here which controls the Z-axis. There's a threaded rod which causes this carriage to go up, 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 up. And then back down here, we've got another motor on another track and another belt, which causes the thing to move in the Y direction. So this thing moves the extruder in the X, this moves the bed in the Y. There's another thing that moves it in the Z, and that's kind of how it works. It's a big dance. The filament gets heated up, extruded, and spit out the bottom, kind of like it was a piping bag for a baker. 3D printers print models. There is a file format, like TXT or JPG, well, there's one called STL, which stands for stereolithography. And people generally use CAD, computer-aided design, to build these models. Or you can download them from libraries. People design things like this, like all these models, and they store them in libraries. And if you want to, you can download them. They're generally in HO, or you can build your own. These two I made. I always wanted a hot tub. My wife said no, but I made one in HO. And this is room dividers for a DPM model, which I eventually illuminated using an Arduino. So you don't have to design your own stuff. You can download some pretty nice models. But if you want something of your own, you're going to have to design it yourself. And it ain't easy. But this is what you're going to see today. This model of a log cabin, with the exception of the chimney here, was all designed in PowerPoint. I designed the logs in PowerPoint, the door, the window, the roofing, all designed in PowerPoint. And you're going to learn how to do that today. The 3D model software, people hear about Tinkercad, SketchUp, and Fusion. It can be pretty hard to learn. You end up working kind of an environment like this. But I'm also going to teach you in 6 minutes how to use Tinkercad. If you use a real thing like SketchUp or Fusion 360, which is what the very best modelers tend to use, Everyone is going to tell you it's tough to learn, and they're right. But there is another way. And that's what we're going to talk about today, using PowerPoint as a CAD package. Now, many of you, if you've ever done presentations, you've used PowerPoint. But if you've got any other kind of drawing package, or even if you use the drawing package in Word, you can probably use it to design a model. That's what we're about today. We're going to learn how to draw an object in PowerPoint, save them as a PDF, Adobe's portable document format. We're going to learn how to convert them to stereolithography, slicing and printing. This is going to be the graduate course, printing in layers. Even if your printer can only print one color, there is a way you can make it print in two. And we're going to talk about the 9 must-knows for any piece of CAD software. I'm going to give you a 6-minute lesson on CAD. And at the end of that, you're going to be able to use Tinkercad. If you write down nothing else, this is it. This is my website, DAACKM.GITHUB.io. This is going to come up several other times. So if you're still looking for your pencil, it's going to come up. And that is probably the most important thing that you're going to learn today. And why is that? Well, if we go down to my website, here it is. There you see it again, DAACKM.GitHub.io. And you go to the top and you got my welcome screen here. And if you start scrolling down, you see every clinic I've ever taught. This is the new one that's going to be released at the end of July.
David, mine is blank.
That's not
Dave, we've lost your picture. We've lost your picture.
Oh dear.
No, it says end of slideshow. Quit the edit.
Okay, what we're going to do is I'm going to stop this share, and I'm going to start sharing again. And I'm going to where is it here? There we go. All right, seeing it now?
Got it.
Okay, so if we scroll down, this is my new clinic that I'm starting to talk about here. But here's the thing on 2.5D CAD using PowerPoint. If you want to, you can go see the whole clinic here. If you want to see a 90-second trailer, you can do that. Links to sign supports, all these other things. If you want to do a picket fence, well, I've done a PowerPoint for that already. And so all this stuff is here. If you want to go back and see it again. So this is where I store all my stuff, is on my own website here. And I got to think about, the one of you who wanted to find Murphy images. Well, I also teach something on creating custom decals, so that could be interesting too. Okay, I'm going to stop the share of my website, but you guys know that that's where everything is right now. I'm going to start the share again, and this time we're going to start playing the clinic. And here we go. Now, this is going to be a video that I already have in the can, and I'm going to stop it from time to time and maybe make some additional comments. I released this clinic back in August for the first time, and I've learned a few things as we go along. I think I've also lost weight. So we're going to run this, and if you've got any questions, you can interrupt me and I'll pause it. I'll stop a couple of times as we go through for questions. So here we go. We're going to have a ride. Creating 3D objects for model railroading is a lot of fun. Learning how to create them with 3D computer-aided design software is not. The software is complex, and learning how to think and design in 3 dimensions is not a skill most people have. But this clinic will give you the simple tools needed to be productive designing model railroad objects using skills you may already have using Microsoft's PowerPoint. That's quite a claim. So how is this going to work? You probably already know that PowerPoint is Microsoft's computer program to create presentations. It's been around since 1987. You may already know how to use PowerPoint's technique to insert a shape into a slide. You can combine several shapes into something recognizable and useful in model railroading. What you may not know is that you can save PowerPoint's shapes into a portable document format, or PDF. You probably do not know that you can convert a PDF into a 3D model and print it on a 3D printer. That's how a 2D drawing can be converted into a three-dimensional object, hence the title of this clinic. 2 plus 3 is 5, and divided by 2, we get 2½D. The details are the subject of this clinic. The key concept here is extrusion, and here is the first extruder I ever used, a cookie press. With a twist of a knob, it extruded cookie dough through a die and deposited it on a cookie sheet. Another example would be a piping bag that a baker uses to deposit cake icing into roses. A 3D printer isn't much different. Mine heats a filament, extrudes it through a circular nozzle, and like the piping bag, moves the nozzle around in the X, Y, and Z directions to build up a 3D image. If we could create a die like used in the cookie press, we could instruct our 3D printer to extrude filament in the two-dimensional shape of the die, and then specify the desired height of the extrusion. That is exactly what we will do by creating 2D shapes in PowerPoint and printing them in 3D. Let's check out a few samples of what I have created with this technique. Here is the city limit sign. The decal is one I made in my decaling clinic, but the sign and post are two rectangles drawn in PowerPoint, extruded to 2 millimeters, and printed. Here is a drawing of board and batten siding as seen from the top, and the wall that results when the outline is extruded 35 millimeters in the Z direction. The thing that we're learning here is look at the world on edge in 2 dimensions, and then how can we convert it into 3? Board and batten siding. We can use the same technique and create corrugated roofing for a shed. A picket fence is certainly within reach, as is a gate that you might find blocking a road. Even something as complex as a trestle bent is simple to draw in PowerPoint. Simple applications like these can add value to your model railroad. Imagine what you might be able to do if you glued a few of these pieces together. And if you are willing to learn just a very few techniques using a free, simple package like Tinkercad, you will be astonished at what you can accomplish. So how is this going to work? Let's start by designing something simple, the city limit sign. If I look at it straight on, I see that it is just 2 rectangles, one for the sign and one for the post. I model in HO, and from my work in creating custom decals, I know that the sign will look good if I make it 1/4 inch tall, which in HO translates to 21.7 real inches. So I use PowerPoint's Insert Shape function and insert a rectangle. I'm sure you probably can draw a rectangle that is exactly 1/4 inch high, but I cannot. So I right-click on the rectangle and click on Size and Position. I alter the height to 0.25 inches and alter the width to some value that I think will be a bit wider than the name I wish to place on the decal for the sign. Similarly, I draw a slender rectangle for the pole. Something 0.05 inches would represent a 4x4 in HO, and we can make it as tall as we like. I place the pole roughly where I want it, select both objects, and use the Align function to align their centers. With all the shapes selected, I again right-click, select Format Shape, Line Color, and then No Line. My technique works well with solidly filled shapes, but lines are problematic. Finally, I've learned later on that the lines really aren't as much of a problem as I thought. I click on Size and Position and either remember or write down the width of the object. I want to save the design, so I click on the File tab and give it a name of City Limits. My version of PowerPoint, version 2010, saves the file in a .pptx extent. But did you know that if you click on File, then Save As, you can save the file in many additional formats, including a PDF file? So I select the PDF file type and save the image as a PDF as well. Perhaps there is a CAD package somewhere that can work with the PDF, but if there is one, I am not aware of it. What I am aware of is a website, anyconv.com, which can convert a PDF into a stereolithography file, a .stl file, which can be imported directly into the Cura slicer, from which we will then be able to print our objects. We just open the website, select our PDF, tell the website to convert it into an STL file, and then click on the Convert button. When the conversion is complete, we click on the Download button, and the new STL file appears in our Download folder. Let's get ready to print it. Many of you know that slicing is the process wherein the STL model file is converted into instructions to drive your specific model of 3D printer. For the rest of you, I use free software called Cura to slice my model files. To open our STL model file, I click on the File command, then on Open File, and select the STL file that anyconv has created for me. Note that the dimensions are not as I created them in PowerPoint, because inherently, STL files never contain the measuring units used to create them. I believe that anyconv and PowerPoint both use inches, but that Cura assumes millimeters. Thus, if you go directly from anyconv to Cura, the ratio of the X and Y dimensions are correct, but the absolute sizes are not. It would be nice if there was an import option in Cura to allow us to specify the import units we desire, but such is not the case. No matter. After importing, I just click on the imported object, and then on the left edge, I click on the icon that looks like a black hourglass in front of a larger white hourglass. This icon then lets us alter the size of our object. Just enter the desired width of the object, which we wrote down earlier, or which you promised you would remember without writing it down. In millimeters, 25.4 millimeters per inch, and the proper size is restored. Now, I'm guessing you probably want to alter the height of the Z-axis while preserving the dimensions of the X and Y axes. With the sizing icon still selected on the left edge of the window, I click on the Uniform Scaling checkbox to deselect it. You can now specify the amount of extrusion height you want, and for the city limit sign and many walls, 2 millimeters is a pretty good choice. It helps me to remember a few ratios. In HO, 10 real feet scales down to 1.38 inches, and 1.38 inches converts to 35 millimeters. So 2 millimeters is a bit under 6 inches. You can try to scale it down further if you think your 3D printer can render that successfully. Now I click on the Slice button and then on the Save button to save the G-code to my SD card, which I then transfer to my 3D printer for rendering. Your printer may operate similar to mine or may not, and I'll leave the actual printing methodology up to you and your user's manual. Let's take a look at a few more samples. This is a gate, which is very similar to the city limit sign. It is just a collection of 5 thin rectangles. I made mine 0.08 inches wide. 2 of them are neither horizontal nor vertical, but rotating an object in PowerPoint is simple. Just right-click on the object to select it, and then select the Format Shape command. Click on Size and Position. Specify a new rotation angle and close the menu. Your object will be rotated as you specified. Or click on the small green circle just outside the shape and drag it to rotate the object. Where objects intersect, I always place the complete end of one object over the object with which it intersects. That way, I always get a good connection between objects with no gaps. To my HOI, the gate looks good extruded to 2 or 3 millimeters. You can use the same technique to create non-rectangular supports for signs. I used a swag shape to create a sign for a rummage sale. From the same shape, I made a much larger sign for an entry gate to a county fair, adding some scallops to the bottom. I also made decals using PowerPoint, and the technique is covered in a separate clinic available at my website, http://dackm.github.io. You are really limited only by your imagination. Similarly, we have the Trestle Bent. The individual pieces are all 12 by 12s, which in HO make them 0.14 inches square. I made 3 of them for the top, middle, and bottom, and spaced them about 12 feet apart vertically, or 1.57 inches in HO scale. I made some more 12 by 12s, rotated them vertically, and spaced them about 0.34 inches apart, left edge to left edge. I added more supports, rotated 6 and 12 degrees, and copied them to the opposite side. I stretched the pillars appropriately and the horizontal timbers as well, and I had an object I could extrude to 3.5 millimeters and print. In my clinic on building billboards, I created legs, face frames, and a boardwalk out of pieces of styrene, but the 2.5 D CAD technique makes this much easier. I make billboards in 5 sizes, scale to 8, 10, 12, 14, and 16 feet high in HO, and they are available via the links on my website, http://dackm.github.io. Each set contains 4 legs, a boardwalk which you can cut to size, and pieces to frame the artwork you can create yourself or download from the internet. To fit properly, make sure your artwork matches the scale sizes described earlier, typically 1.10 inches, 1.38, 1.65, 1.93, and 2.20 inches respectively. To match the heights of the support structures described earlier, we are constraining the height of the billboard artwork, but the width of the artwork is free to be any size you desire. This means that you will need to resize the horizontal frame pieces to be about 0.2 of an inch wider than your artwork to allow for the width of the frame. The vertical frame boards are already sized to match artwork that matches the proper HO scale. How we doing now? We'll take some questions now. Basically what you've learned is you can draw things in PowerPoint, you can save them as PDFs, you can go to that anyconv, ANYCONV.com, and extrude them and convert them into an STL. By default, they're going to be 20 millimeters in the Z direction, but you can change that in the slicer and get what you want. So, any questions before we go on?
Dave, I guess I was just wondering about a depot. I forget what the name is for those things that support the roof under the depot.
Rafters.
Rafters. I was wondering, I guess I used to mold or used a mold to make some, but I could probably make them in 3D probably easier.
I have. Yes, indeed. That little log cabin that I showed you at the very beginning,
Yes.
inside there are 7 rafters. And if you think about it, a rafter is the same thing as making that gate. It's just some different shapes. So you just have to make sure you know the pitch angle of your roof. And then you draw it, and there are rotation. You saw the rotation parameters in there, how you can rotate them to the appropriate degrees. And yeah, rafters are like falling off a log, so to speak.
Oh, even if they're curved, I guess.
Well, if they're curved, they're harder to draw, but they're no harder to print.
Oh, okay. All
So
right.
yeah. Okay.
Thank you.
Anybody else?
Yeah, Dave, Harold Weinberg, I have a question. I've been thinking I might do some scratch building and thinking about using a CAD program.
Yeah.
To make plans.
Yeah.
And I experimented with one Fusion 360, which seemed very difficult.
Yep.
And not worth the time I would have to take to learn to use it. You mentioned Tinkercad, which I gather is a better choice.
It's a simpler choice.
It's what?
It's simpler and it's free.
Okay. And do you think, though, that you could use PowerPoint to create plans for a structure, let's say? Would that work as well as a simpler CAD program like Tinkercad?
Stay tuned, brother. You're about to see it in about another 25 minutes. I make my walls in PowerPoint, and then I composite them in Tinkercad. And it only takes about 6 minutes of instruction to learn how to use Tinkercad to the point where you can composite things together, like doors and windows and walls and roofs. So yeah, and I'm going to teach you that a little bit down the road. Okay.
Thank you.
Anybody else? Let's roll. I made 2 variations of board and batten siding, one with an interior board and an exterior batten, and another with an interior batten and an exterior board. Here I drew a rectangle 8 inches in width and 0.06 inches tall, and positioned it in the upper left corner of the page at 0, 0. I then created a small square. Using format shape, I sized it to 0.06 inches and positioned it 0 inches from the left edge of the page and an inch below the top of the page. I made 11 copies of the small square. I took one of the small squares, and again using format shape, I placed it 7.31 inches from the left edge of the page. I then selected all of the small squares, but not the long rectangle. I clicked on Arrange, Align, Distribute horizontally, and then on Arrange, Align, Top. Next, I clicked on Arrange Group. Now, using the format shape, size, and position, I positioned these 12 small squares at 0.00 inches from the left edge and 0.04 inches from the top, giving them a 0.02 inches overlap of the long rectangle. Finally, using Control-A from the keyboard, I selected all of the objects. I used Format Shape, Line Color, to turn off the borderline around all the objects and saved the file. Voila! Board and batten siding. When printing, I will resize the X dimension of the object to 42 millimeters to translate this 8-inch object into 12 scale feet in HO. Set the Y dimension to 2 millimeters because I like all my walls to be 2 millimeters thick, and I will set the Z axis to whatever height I want for the siding. In HO, 8-foot high siding translates into 28 millimeters. To make it look like the battens are behind the boards, I selected all of the small squares and increased their horizontal size from 0.06 inches to 0.55 inches. They're 0.67 inches apart, so I'm going to shrink the amount of distance and make the squares bigger. You can choose a different width than 0.55, but that size looked good to me. Similar to board and battens is this corrugated roofing. It's just a matter of alternating hollow circles. Here is a sample of clapboard siding. I started with the thick board and batten siding from the previous sample and moved the small blocks down so that they were no longer overlapping the larger rectangle, but still touching it. I also increased their width so that each touched its neighbor. Using the Edit Points function, I then deleted the lower right point from each of the small rectangles. Doing this for all of the smaller rectangles resulted in some nice clapboard siding. I tend to think of siding being in 12-inch segments, so by having 12 triangles in our drawing, we are limiting ourselves to 12 feet in height. But remember, we can duplicate our siding piece, abut the second to the first, and group the two before creating the PDF. We will set the exact dimensions in the slicer, or we will see in a bit. We can combine walls with windows and doors for a creative effect. I've made some walls, so now I am going to make some windows. I start by drawing a rectangle for the window frame. Arbitrarily, I'm going to make it 1 inch wide and 1.5 inches tall. I'll rescale it to final dimensions when I slice it. I'm going to have 4 cutouts for window panes, and these are going to be a 1/2 inch tall and 0.33 inches wide. These dimensions are arbitrary, so change them if you like. For better visibility, I am going to color the pane yellow. I duplicated the pane and moved it over a bit from the first pane, aligned their tops, and grouped them. I duplicated the pane group, dropped the second pair down under their siblings, and center aligned all 4. I grouped all 4 panes. I then moved all 4 panes over the frame and center and middle aligned the panes over the frame. Finally, I ungrouped the panes into 2 pairs and then ungrouped the pairs into individual panes. I now have 5 individual objects nicely aligned into a window. Now for something you may not know about PowerPoint. Do you see on my window in the upper right is a group named Shape Tools? You probably do not have this group, as by default it is not visible in PowerPoint 2010, but you can turn it on. How? Click on the File tab, then on Options and Customize ribbon. In the lower right of the window, click on the New Group button and rename it something like Shape Tools. In the upper left of the window, there is a drop-down box labeled Choose Commands From. So pull down the menu and click on Commands Not in the ribbon. The commands right below the drop-down box will change. Select Combine Shapes from the list, then on Add to add it to the Shape Tools group, then on the OK button. Now that we have customized the ribbon, select all of the shapes. The Combine Shapes group will become active and options will appear. Click on Shape Subtract, and since the 4 panes are in front of the frame, all of them will be subtracted from the frame, creating holes. You have just created a window. As before, we will use anyconv.com to convert the Windows PDF to an STL file and alter the final size in the slicer to 10 by 15 millimeters, 2 millimeters tall. Later in this clinic, we will show how we use Tinkercad to combine shapes, and we will add this window to a wall. A simple door is not much different than our window. Unfortunately, we can't uncombine our object. We could decide to start from the beginning and draw a larger frame, but fortunately for us, we can use PowerPoint's undo function to go back a step. A standard exterior door is 80 by 36 inches, so I'll set the height to 2.2 inches to maintain the proper aspect ratio and recombine the window panes, and we have a door. And speaking of doors, let's create one that is okay. You've seen a lot of the good stuff so far, and we're about to get into something that's the graduate course, how to do things in 2 colors. So I'm going to stop again. Any questions? Okay, hearing none, here we go. This next about 5 minutes on doing layers is pretty complicated. So if you don't get it, you're okay. We're coming back to doing more that's more simpler just in a little bit. But this is how you can get a 3D printer that only prints in 1 color at a time to do 2 colors. It's a bit more sophisticated. I want something rustic, so I am going to start with the STL file of the thick board and batten object we created earlier. Because I want fewer than 12 boards for my door, I'm going to make a copy of the page, select the object, ungroup it, eliminate 6 of the panels, and change the width of the backer board to 3.88 inches. I save the page as a PDF. When saving the door, I need to use the Options button to save only the current slide to the PDF file. You may wonder why I don't use the Selection option in the Save File panel. Well, it's not a highlighted option in PowerPoint 2010, so I can't select it. I have to separate my objects into discrete pages. Now I am going to add another page to this PowerPoint and draw 3 rectangles in the shape of a Z and save it as another PDF. As before, I use anyconv.com to convert the door and the Z file to a stereolithography format. In the slicer, we import the door's STL file and then click on the door to allow us to change how it prints. So far, when using Cura, we have printed our object standing on edge, but we are not required to do so. On the left side is a slicer tool, the third one down, which allows us to rotate our design in the X, Y, or Z direction. So I click on the tool. 3 circles appear to allow us to rotate the door in each plane. I click on the bottom part of the red circle and using the mouse wheel, drag it upward, noting the change in the rotation angle as I do so. When it gets to 90 degrees, I let go of the mouse and the door flops down flat to the build plate. Several strokes of the red circle may be needed to get the door perfectly flat. Remember, it goes flat to the build plate, like right on it, for now. Next, I want to change the size of the door, and another slicer tool allows me to do so. I click on the tool that looks like two hourglasses, and a box opens where I can alter the dimensions. Since I want to alter the dimensions disproportionately, I make sure the uniform scaling box is unchecked. A standard exterior door is 80 inches tall and 36 inches wide. So for HO scaling, I set the X dimension to 10.5 millimeters, the Y dimension to 23 millimeters, and the Z dimension to 1.5 millimeters. Remember that 1.5. Now I slice the door, save the G-code to a file, and print it. Have you ever noticed that the Cura slicer, by default, always centers our projects on its table? We are about to use that knowledge to overlay the Z on top of the board and batten we just printed, and print it in a different color filament. After printing the board and batten, but without removing the door from the build plate, start a new project in Cura and import the Z. No need to flop this one over, as it is already parallel to the build plate. Size it to the same X dimension, 10.5 millimeters. Reduce the Y to about 18 millimeters, but set the Z dimension to 0.5 millimeters. It is not obvious, but the Cura slicer by default always drops any object it prints to its build plate. But I want the Z to rise above the build plate so it can be superimposed to the door. To make this happen, I click on Cura's Preferences tab, then on Configure Cura. A Preferences window opens and I click on Printers and then on Machine Settings. A box labeled Start G-code appears in the lower left. I want to add an additional line at the top and the bottom of this code, so I click inside the box, use the arrow keys to move to the upper left if necessary, and enter M206, a space, Z-0.00, and the return key. I then use the keyboard's arrow keys to move to the bottom right of this box, where I enter a return key to begin a new line. I enter M206, a space, Z-1.48. And remember that 1.48 as well. I then position my mouse following the last line in the end G-code box, hit the Enter key, and enter M206, a space, Z-0.00, and close the window. The changes will be saved automatically. M206 is a special G-code command which, in our case, adds a displacement of 1.48 millimeters to all subsequent Z-axis parameters, thus raising the Z above the door. Now when I slice and print the Z, it will float above the door and adhere to it. Pretty cool. Why did I choose the number 1.48? I chose 1.48 millimeters as the Z-axis displacement because I want the Z to be ever so slightly attached to the door. And since the door is 1.5 millimeters thick, this displacement of 0.02 millimeters will do the trick without destroying the door. After printing the Z, go back to the Preferences, drill down to the Start G-code settings, and place a semicolon in front of the M206 Z-1.48 line, which changes the line into a comment, thus deactivating it. Otherwise, all your subsequent prints will be elevated from the build plate and turn into spaghetti monsters. It's also a good idea to turn off your printer and back on after printing any elevated object. At any later time you again wish to superimpose one object on another, all you need to do is remove the semicolon and alter the displacement as desired. Want a picket fence? I decided to create mine out of 1 by 4 inch boards with a 2-inch gap between boards, and it should be 8 feet long and 42 inches tall. I drew a rectangle 0.33 inches wide and 1.75 inches tall and positioned it at the upper left corner of the page. I copied this rectangle 15 times. I took one of the rectangles and repositioned it 7.5 inches from the left edge. Again, using the trick we learned with the board and batten siding, I selected all of the rectangles, distributed them horizontally, and aligned their tops. I grouped them all. The fence posts need some stringers to hold them together, so I drew another rectangle 0.33 inches tall and 8 inches long and placed it near the top of the posts. I copied this stringer and placed it near the bottom of the posts. You may want to add a third stringer in the middle. If you want a bit more visual interest, you can always dog-ear the first post before duplicating the other 15. Draw the first post a bit shorter and add a triangle or trapezoid on top. Then group the two shapes before duplicating. I want to create room pods to allow a structure to have individually illuminated rooms. When I first designed a building interior to have individually illuminated rooms, I did so entirely in Tinkercad. Subsequently, I designed the interior of this building using the 2.5D technique, and it was a lot easier. Just measure the inside of the building and design your walls and floors accordingly. 2mm walls and floors work well. I glued a piece of sheet styrene to the back of the pod to create the back wall. I used 5-volt LEDs to illuminate the rooms and made them light at random using an Arduino and a random illumination program or sketch, which is available on my website under the Amazing Arduino Animations heading. Remember when we printed the door and overlaid the Z on top of the board in Batten? We are going to repeat that trick and create a billboard with slats and in 2 colors. This PowerPoint file has 3 pages. The first has some slats and the letters of our radio station. The second has just the slats, and the third has just the letters. Why did I design it this way? I wanted to make sure that the letters were sized appropriately before moving the 2 objects into separate pages for printing to their respective PDF files. Note that the height of the type and the height of the slats are identical. This is important because it allows the type to bond well to the slats. By the way, you can choose any PowerPoint typeface you desire. The technique works as well with type as it does with shapes. I extruded the slats to 2mm. Once we have created the PDFs and converted them to STL files, print the slats in an appropriate background color. I chose black. After printing the slats, change the filament color for the lettering to something that will contrast with the slats. I chose white. Like we did when we printed the Z for the door, change your slicer preferences to prevent dropping objects to the build plate. And finally, raise the letters 1.98mm. The letters will print on top of the slats and bond the 2 parts together in 2 colors. Neat! Just remember to reset the preferences back to automatically dropping objects to the build plate. Not only can you create objects for your railroad, you can also create tools. Here I created some wedges and angles I find useful. You can also create gauge blocks to help you duplicate dimensions for traditional styrene or wood construction, eliminating the need to measure for cuts you may want to duplicate at a later date. Not much more difficult than a simple window is a stained glass window for a church. I started by searching the internet for stained glass windows church images. Okay, we're going to go back here just a little bit because of what I heard about you all trying to do the Murphy decal. If you go to the internet and just search for something like stained glass window images, you can find a lot of stuff. So you might look for Images Murphy and see if there's something there you can download and turn into a decal. A church. I started by searching the internet for stained glass windows church images. When I found one I liked, I right-clicked on it and saved it to a file. I imported the stained glass image into PowerPoint and sized it to my liking. Now I want to make a frame for it. I added a rectangle to my page, and using Format Shape, I set the fill property to No Fill. I positioned and sized the rectangle such that it surrounded the image of the glass. Did you know you can get greater precision when moving or sizing a PowerPoint object if you simultaneously hold down the Alt key while moving your mouse? I right-clicked on the rectangle and selected the Edit Points option. I moved the mouse over the top line segment until it was both over the top of the window and the upper rectangle line. It changed from 4 arrows to 4 straight lines, and I right-clicked on the location. A menu appeared, and I clicked on Add Point to add a new control point to the rectangle. Similarly, I added points to the 2 vertical lines, just where the window transitions from straight lines to a curve. Finally, I deleted the upper left and upper right points. Now I went back and clicked on the point at the top, and 2 small white boxes appeared. These control the slope of the line at this point. I clicked on the one on the left and moved it leftward and downward, so the line began to follow the left edge of the dome. I did the same thing to the point at the top of the left edge, and refined the locations until the former rectangle matched the shape of the image. I did the same thing to the right side. I now have a shape that matches the outline of the window. I made a copy of the page and deleted the image. I made a copy of the outline, enlarged it a bit, and aligned it with the smaller version. With both pieces selected, I formatted the shapes, removing their lines and replacing their fills with a solid color. I combined and subtracted the shapes, and now I have a frame for the window. I made an accompanying stained glass decal for the glazing, applied it to clear styrene, glued the window to the frame, and my object was ready to be applied to a church wall. We have learned how to make signs, walls, windows, and doors with PowerPoint. But to put a window or door into a wall, we can benefit by learning just a small amount about a simple CAD package. By the way, Tinkercad is free. I use Tinkercad, a web-based application you could use for free at http://www.tinkercad.com. If you have never used a CAD package, investing 6 minutes now will open your mind to what can be accomplished with the primitives we created in PowerPoint. Once in Tinkercad, we click on the Create New Design button. Now, let's import the clapboard siding wall that we created earlier. We click on the Import button and navigate to the STL file we produced in anyconv.com. Leave the default set at millimeters, but change the scale factor from 100 to 25,400 and begin the import. Tinkercad gives our design funky names, and I like to rename them something more appropriate. So I highlight Tinkercad's default name and enter something like Garage Wall. Now for some basic navigation. You can rotate the entire work plane by holding down both the Control key and the right mouse button, then moving the mouse. You can pan around the entire workplane by holding the Shift key and the right mouse button, then moving the mouse. You can zoom in and out by using the mouse wheel. If you want to get back to one of the basic views, just move the mouse to the square in the upper left and click on one of the words in the cube, or a triangle just outside the cube. We can alter the dimensions of our imported object. You may remember when we printed an STL file in the Cura slicer, we had to alter the extrusion height to our desired value by clicking on the object and entering the height we wanted. In Tinkercad, to make it taller, we just click on the object and then on the small white box at the center top. Yes, we can drag the box up and down to alter its height, but I prefer digital accuracy, so I click on the box with the numbers and enter my desired height in millimeters, 35 millimeters. I want to rotate the wall so that it is lying on its back. I use the Control right-click navigation method to rotate the workplane so that I can see a portion of the side of the wall. You don't have to be perfectly accurate here, just so you can see a decent chunk of the side. Now, when you click on the wall, in addition to the small white boxes, you also see some arcs. Yes, we could click on the arc icon and move the mouse to rotate the object, but I like to click on the arc and then on the digital entry box and enter -90 to rotate the wall to its back. The wall now looks like it is levitating, and it actually is above the workplane. To drop it back down, we just make sure we have the wall selected and then hit the D key on the keyboard. Now for the fun. Click on the navigation cube in the upper left and then move it around so you are looking at the face of the wall. Since we rotated the wall, its front face is in the top view. Let's orient the wall so that its bottom is aligned with the bottom of the workplane. With the siding selected, click on the arc at the left and enter 90 to rotate the siding. Now to size it, click on the black square on the left edge, then on the dimension, and change it to 75 millimeters. Similarly, click on the black square on the bottom edge and change it to 45 millimeters. This is to make that garage for that tractor that you saw at the beginning. And the square in the middle to 2 millimeters. Now, click on the gray and white cube under Basic Shapes at the right of the window and drag it on top of the wall. We are going to create a hole for a window. The hole is 20 millimeters tall, so reduce its height to 2 millimeters. Also, adjust the X dimension to 10 millimeters and the Y dimension to 15 millimeters to match the size of the 4-pane window we created earlier. Hold the Shift key down and select the wall as well. Click on the group icon at the top. You have now punched a hole in the wall for a window. You can take the window we printed earlier and snap it into the hole. If it doesn't snap in perfectly, you may need to use a file to do some final fitting, but there is another way. Make a duplicate of the previous wall and ungroup the wall and the hole. Import the 4-pane window and place it below and to one side of the hole. Set the height of the window to 2.25 millimeters and align it with the hole such that the window moves but not the hole. Group the wall and the hole, and then group the wall-hole combination with the window. Now when you slice and print this project, the wall and the window will print as a single object. Using this technique, you can add as many windows and doors to a wall as you like. When you are done, you can decide if you prefer inserting a window into the wall by pressing it in with your fingers and gluing, or printing the wall and windows together at the same time. I tend to like the second method, but the first method does give you the option to print the windows in a different color than the walls, or paint them before inserting them. Here we have placed it all together. In Tinkercad, I started with the siding we designed in PowerPoint and added holes in the walls for windows and doors. I made the holes just a bit wider and taller than the windows, 0.6 millimeters, to avoid having to file the windows down to size. Your 3D printer may have tighter or looser tolerances than mine, so you probably will have to experiment to get the sizing to suit your needs. I changed to a green filament and printed the corrugated roof from PowerPoint, a center support beam, top vent, and moldings to cover the wall joints. After assembling, I had a shed for my tractor. Well, we may be out of time on 2.5D CAD using PowerPoint, but we are never out of ideas. Culverts, bridges, loads, and much more are all within our grasp, even if one has never before used a CAD package. Remember, it's not the tools that make someone a craftsman, but how creatively one uses the tools one has. Thanks for participating.